This is the ball drilling jig that I use to make molecular and geometric models. Right here is the general shape. It has 26 faces and 26 holes in the center of each face. Each one of the faces is exactly the same distance to the center. It's held together by friction. Let me see if it, whoops. Oh, there it is. Just wooden dowel rods hold it together, and that's enough to keep the ball from spinning while you're drilling. This shape is made by taking a cube, cutting all edges off, all 12 edges off at a 45-degree angle, and then cutting off 8 corners at the octahedral angle. So I have this set up for the octahedral angle. So to make the cuts, I'll take my block of wood. There's double-sided sticky tape all along here. This is super glued on, so I'll stick this on there. And then take another piece of wood and use both hands and just pinch it in there like a little vise. And then set this edge up against my table saw, slide it in, rotate it quarter turn, do that 4 times, and then flip it 180, and then you'll get your 8 octahedral faces that way. You can use it just as a cube like this right here, but you don't have very many angles and they're all 90 degrees. So the angles that you do have on this shape are pretty varied, as you can imagine. You do have a really important one for making chemistry models. You have the 109.47 degree angle, which is between one octahedral face across to another. And that comes up quite a bit when you're making chemistry models. So here, I'll just show you some of the stuff that I've made. This is a tetrahedron, a red tetrahedron facing up and a yellow one facing down. A regular dodecahedron, yeah. You can make 4 of the 5 platonic solids. This is the diamond cubic lattice. This would be a crystal of diamond magnified. Each one of those balls would represent 1 carbon atom. That has the tetrahedral bond angle, 109.47 again. This is a stellated octahedron. There's an octahedron in the middle surrounded by 8 tetrahedrons. You can see it's kind of a neat shape. It has lots of equilateral triangles on it. This is octasulfur, 8 sulfur atoms arranged in that shape, a tetrahedron, and a tetrahedral ball puzzle that fell apart. It's made with 4 pieces, kind of a neat little puzzle. This is a rhombicube octahedron. That's actually the same shape as this ball drilling jig. So you can see that. Yeah, you can't really. This is a molecule of dicamba. That's an herbicide. Back there is an LSD model. I haven't finished yet. I need to put hydrogens on it. Benzene ring, cube, octahedron, body-centered cubic unit cell. So this would be what like iron metal would be crystallized in. If you imagine each of those would be iron atoms, that's the shape that it takes. Methane. Oh, that's how I paint them. I just use spray paint, stick dowel rods in them, and then poke them into that foam to let them dry. Tetrahedron, another octahedron. This is kind of cool. A yellow tetrahedron inside the red cube. And then over here, I have a rhombic dodecahedron. I used TIG welding rods to fasten that together. So anyway, that's the ball drilling jig. Oh, and back there are just the combination of shapes that are in this jig. So you combine, all these faces get combined to make this shape.